Hello there. Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. This is of course from Hitchhiker's Guide to the Galaxy. So if you want space exploration, you have two options. You can either reduce journey time or journey distance. So we recently explored different methods of space travel for the Star franchises in Star Trek's Warp Drive, Star Wars' Hyperdrive, and Stargate's Stargate. These varied methods do both accelerating to FTO to reduce journey time and connecting different points via a shortcut or reducing journey distance. But which franchise does space travel best? Today, we find out using an entirely arbitrary point and rating system based purely on my own opinion. Ratings. Each of the past videos have followed the same structure: background, statistics, science, IRL science, risk, and each metric is equal, but some are more equal than others. So we are applying a purely subjective multiplier from 1 to 2 to enhance these scores for each metric to account for how important the metric is overall in the discussion. So the background isn't getting a score as it doesn't actually affect space travel. It just provides some lore to each franchise. Statistics. Rating 1.75. This is definitely an important metric, as any discussion on who does space travel best needs data to show which is fastest. However, it can be used in a way to fulfill any plot requirement, so it won't give a definitive answer, as any franchise can make their method the fastest if they so wanted to. Science. Rating 1.25. The lore behind how FTO travel works matters, otherwise there's no point having it, but as it's all fiction, new elements or aliens can just be invented to allow for exceptions to reality. For example, dilithium mediates the reaction between deuterium and antideuterium as it won't react with antimatter. Any real compound would react with antimatter, but as dilithium is fictional, who's to say it wouldn't react with the antideuterium? So all the franchise needs to do is have a method that sounds plausible and be consistent. IRL science. Rating 2. It's a whopper of a rating, and that's because space travel must be possible for any sci-fi show exploring space, whilst we are simply stuck imagining how to traverse space beyond the asteroid belt. So it is interesting to see how science influenced sci-fi concepts, and how sci-fi has gotten scientists inspired to apply fiction to reality. So maybe, one day, fiction will become reality, so it is the most interesting to me. Risk. Rating 1. Everything has risk. Too many hours have been spent filling out risk assessments for simple, safe activities. Space travel is not simple, or even safe, with all those fuel sources being able to explodificate, but we simply just need to be aware of the risks and how to mitigate them. So our own transport uses flammable fuel, so risk is just there, and any action set piece would be pretty dull if everything was safe all of the time. Summaries. Background. Only Star Trek uses a futuristic technology to achieve faster than light speeds, with humanity achieving Warp 1 on the 5th of April 2063, and uses a mathematical formula to calculate speed, so speed equals warp factor raised to the power of 10^3 multiplied by the speed of light in a vacuum, and this scale stops at warp 10. Both Star Wars and Stargate uses old technology. Star Wars' hyperdrive was made in 25,053 BBY on Corellia and Duro, whilst the Stargate found in Antarctica was constructed over 50 million years ago. Statistics. You can't improve upon a Stargate. The average journey time, once the gate is dialed, is 3 seconds. It would take longer to walk up the ramp than to travel to a different planet. Star Trek and Star Wars both have progression with the technology, with warp having a factor from 1 to 10, and hyperdrive having a class to reflect how many times longer the base time a journey would take. So we're going to use the hyperdrive system in Timothy Zahn's Heir to the Empire trilogy, as it has more data available. Warp 3 is a speed of 0.00445 light years per hour. A hyperdrive class of 0.1 is 0.14 light years an hour. Warp 6 is 0.0448 light years an hour, whilst the hyperdrive class of 0.4 is 3 light years an hour. Warp 9 is 0.173 light years an hour compared to a class of 0.5's 127 light years an hour. Science. Both Star Wars and Stargate work by reducing journey distance. Stargate is the most straightforward. You simply dial the address of the place you want to visit, and then pass through the event horizon, being dematerialized and then reassembled at the receiving gate. Star Wars uses an alternative dimension called hyperspace to reduce journey length, like using the Nether in Minecraft. To enter hyperspace, a ship accelerates FTL, and a CMU tunnel forms, allowing a pocket of real space to form in the hyperspace dimension and for vessels to pass through. The fuel needed for this is coaxium, and it is only safe to travel pre-charted hyperspace lanes to avoid any collisions, as objects in real space have a shadow mass in hyperspace. Star Trek reacts deuterium and antideuterium together in a reaction that is mediated by dilithium. This forms warp plasma, which enters the warp nacelles and forms a warp field. A subspace field envelops the ship and warp speed is reached. IRL science. So both Star Trek and Stargate focus more on the science part of sci-fi compared to Star Wars. Star Wars uses hyperspace to reduce journey length. Wormholes can act in the same way, folding space, essentially creating a shortcut to your destination. Hyperspace acts as a separate dimension, and current string theory predicts 10 space-time dimensions, so it stands to reason that if we could access these dimensions and travel across them, we could achieve FTL travel by reducing journey length by using these 10 dimensions. So keeping on the topic of wormholes, travel via a Stargate could be possible. Ludwig Flamm in 1916 theorized that things could escape a black hole via a white hole. The only thing needed to stabilize a wormhole is exotic matter. One example of exotic matter is negative energy density, which, although exists, creating this still poses a challenge. So although travelling FTL for any object with a mass is impossible, because you will need infinite kinetic energy, Star Trek circumnavigates this by using relativistic physics. The Lorentz factor allows for FTL travel without reaching FTL speeds, and is calculated by this formula. Lorentz factor equals 1 divided by open bracket 1 minus velocity squared divided by speed of light in a vacuum squared, close bracket, all raised to the power of 0.5. And we've seen this at work. On the International Space Station, the cosmonauts Sergei Krikalev and Sergei Avdeev both experienced time dilations of about 20 milliseconds compared to time that passed on Earth. So they were travelling at around 7,700 meters per second for 6 months. We can use our formulas to calculate the Lorentz factor in this instance. V would equal 7,700 meters per second, whilst C is 299,792,458 meters per second. And well, this gives a Lorentz factor of 1.00000000000329, which is very small, and that caused a 20-second time dilation. Faster speeds would result in a greater Lorentz factor, and greater time dilations could be reached, reducing relative journey times. So all the fuel sources used, dilithium, coaxium and naquadah, they're all fictional, but deuterium and antideuterium are real and would react together, so Star Trek is closest to a realistic fuel source. Risk. Both Star Trek and Star Wars use vessels to achieve space travel. Vessels use fuel, which needs to be refined and stored. These fuels pose a risk of damaging a person or craft if they are not stored correctly or leak out. Warp core breaches destroy ships in Star Trek, and the warp nacelles are easy targets, and coaxium's volatile, but most ships in Star Wars lack shields, so have bigger problems than a fuel leak in combat. Stargate doesn't get a pass with naquadah. Although you don't need to travel and store it for long journeys, it still needs to be stored correctly, and it will react with potassium. So all the fuel sources are non-renewable, so are at risk of running out in the future. And as Star Trek has the longest time in space, the risk is biggest here, although deuterium and antideuterium can be collected using Bussard scopes. Scoring. Statistics. All the methods are faster than light in fact, but of this, Star Trek is the slowest. Mostly because we spend most time in space exploring in Star Trek, so the plot doesn't need super fast travel times. Warp factors increase in a non-linear manner, and Warp 10 is infinite velocity. As most vessels can hit Warp 9, Star Trek gets a 6 here. So Star Wars has the fastest ships, and the entire galaxy can be traversed quickly. But not every ship has hyperspace capabilities, so Star Wars gets an 8. So the average journey time of 3 seconds is stupid fast. And you can do it at walking speed. Stargate gets a 9. It's only lacking as you need all the hard work of building a gate to have been completed. So travelling to a new planet will be slower, but travel to an already visited world would be near instant. In-universe science. Both Star Wars and Stargate have very little actual lore behind how their respective methods work. I assume because they both use ancient tech, so there just isn't the understanding behind it. You input your coordinates into either a Navi computer or a dial home device, and you just accelerate to FTL or walking speed and enter the hyperspace dimension or the event horizon, so they both get 5 points. Star Trek uses similar science to the real world by reacting the fuel of deuterium and antideuterium together, and has methods to collect these fuels with the busted ramscopes, so as each step is clearly explained, Star Trek gets 8 points. IRL science. So Star Wars is once again lacking, as it's intended to be a space opera, not a science guide to space. If we could traverse theoretical wormholes to access the theoretical 10 space-time dimensions, then we could imitate Star Wars, but this is all theoretical based off some big assumptions, so 5 points. Sticking with wormholes, Stargate also relies upon them, but the show ensured it was scientifically and mathematically plausible. Collecting 2 points in space can be done using a black hole entry point and white hole exit point. Travel through this would be near instantaneous, like 3 seconds, but the problem is stabilizing it. Good news! Exotic matter, like negative energy density, can stabilize wormholes, and we know this exists. We just don't know how to artificially create it. So as this is the only thing lacking, which is the engineering behind the Stargate scores 9. Star Trek uses mostly real fuel sources, and uses this fuel to generate the energy needed to accelerate FTO. The Lorentz factor can be used to technically travel FTO, and this has been seen with the time dilation of 20 milliseconds with a tiny Lorentz factor at a relatively small speed. Scale it up to much greater speeds and you'll get a greater Lorentz factor, so greater time dilations or faster journey times for space travel. So Star Trek gets the full 10 points as we have seen it in action, so all we need is a fuel source capable of producing that much energy. Risk. Stargate is the safest by far. There's no warp core to target or collisions to occur. The only risk is firing up the gate and not getting out the way of the energy vortex, or exceeding the energy capacity. Both are easy to manage, so Stargate gets 8 points. Both Star Wars and Star Trek uses non-renewable sources in coaxium and dilithium, so these will run out over time. However, we have this risk with our own fossil fuels, and it doesn't stop us, as it's future Earth's problem. Both these fuel sources are reactive and need to be stored correctly, so pose risk. These methods differ in one big area. Star Trek has a known weakness of targeting warp nacelles and causing warp core breaches, which is pretty serious. So Star Trek gets a 6 and Star Wars a 7, as hyperdrive's biggest risk is collision, but with continually updated Navi computers and vessels dropping out of hyperspace if a gravity well is encountered, collisions are rare and more likely intentional than accidental. Conclusion. There we have it, the ramblings of one person's opinion. So let's take a look at the overall scores. So without any ratings, Stargate just beats Star Trek by 1 point, and Star Wars is bringing up the rear. Stargate's super safe speeds work in its favour, whilst Star Wars lacked science, real or otherwise, to support hyperspace, leaving it behind. So let's apply the ratings, and this does not alter the results. It just slightly increases Stargate's lead. So we can say Stargate does space travel best. Thank you very much for watching. Let me know your thoughts. Do you agree? Disagree? I'll speak again soon.